In this video, we are going to look at the graph of sine. Now, when we're doing the graph of sine, we are essentially looking at the unit circle, and we're going to fold out the unit circle is what I like to say. So here we have our xy plane, right? So this is my x and my y. And so we're going to fold out the coordinate of the unit circle, the coordinates from the unit circle itself. Okay. So if we recall, I'm just going to fill in the different points, right? So on the unit circle, notice again, unit means we have a radius of 1. All right. So, and that's along this line here. All right. So this point is going to be 1, 0. When we're at the top of the unit circle, we're going to have the point 0, 1. And if you think about this, like if you were graphing on the xy plane, right? And you have a unit, then your points on the y-axis, if you may call this your y-axis if you want to, that's essentially what you would have. So for pi, you would have, now we're on the negative side, so this is going to be negative 1, 0. And then below here for 3 pi over 2, we're going to have 0, negative 1, and so forth. Now, what is important about these coordinates is the value that they hold, right? If you recall in our previous video, we discussed that the cosine is going to coordinate, or the cosine theta is going to be coordinating with our x value or x coordinate, while sine would be the y. So for us, if we are going to be graphing sine, or you can say sine of theta, if we're going to be graphing sine, then we're going to use these different, I call them checkpoints. So we're going to be at 0. Then next, if we go here at the top, right, let me use another color so you can clearly see I'm at the top now. So that's going to be corresponding with pi over 2. Then if I go next, I'll be at pi. So that's going to correspond with pi on my circle, or as I roll out the circle, it's going to be pi. Next, if you guessed it, it's going to be 3 pi over 2. And then we're going to have pi to complete, or 2 pi rather, to complete my rotation. Now, since we're doing the graph of sine, we want to know, well, what are the sine values of each of these? So if you look, when we're at 0, so again, sine is corresponding with my y value for my coordinate point. So that means I'm going to look at all the y values for my coordinates, all of my y values when I go to each of my checkpoints. Okay. So when I'm at 0, sine is 0. So that means that this point is going to be 0. Now, when I'm at pi over 2, sine is 1. So here at my xy plane, this is going to represent negative 1. And this is going to represent 1. So if I'm at pi over 2, sine is going to be at 1. Okay. Then when I get to pi, what happens? Sine is again 0. Then when I get to 3 pi, sine is negative 1. I go down. And when I get back to 2 pi, sine is 0. So now when I connect my dots, this is what my sine function looks like. And we can actually do the same thing on the other side. So you have pi, 3 pi over 2, and 2 pi. But these are all negatives. So let me put the negative signs here. Now, you can think of it if you're going again now in the opposite direction. This would be my negative pi over 2, right? And then this would be negative pi and then this would be negative 3 pi over 2, and then this would be negative 2 pi because we're going in the opposite direction. So notice when we're at negative pi over 2, my sine is negative 1. So I'd go down here. And then when I'm at negative pi, I am at 0. When I'm at negative 3 pi over 2, I go back up. Okay, and then when I'm at negative 2 pi, sine is again 0. And so I can, again, connect my dots. Now you should notice something. The sine graph is repeating, right? So it repeats between, if you notice, every 0 to 2 pi, even in the opposite direction. So this is going to lead us to some characteristics that are going to be very important for us. Okay? And so let's say we have y equals a times sine x, well, sine bx minus c plus d. Well, from these, or from this alone, if we have something like this, we can tell the period, which is the duration for each sine function, and then we can talk about the amplitude. But let me talk about the period first. So the period for the sine graph, like I mentioned previously, if we look here, it's going to be repeating. So we say that it's repeating, but in actuality, we call it a periodic function. That's the terminology that we use. So sine is a periodic function, and it's going to be the same thing or the same graph between 0 to 2 pi and then 2 pi to 4 pi and so forth. And so the period is going to be 2 pi for that reason. Okay? And this is just a standard sine graph. Now, the amplitude for the sine graph is, when we talk about the amplitude, if I come over here again, when we talk about the amplitude, we're talking about the distance from the midline. The midline is going to be the line that is in the middle, serving as just a halfway mark, if you may. So the line that's in the middle is going to serve as our midline. And so here, our midline is 0, okay? But when we talk about the amplitude, that's going to be the distance from the midline, right? And so again, let me use a highlighter here so we can see. This is my midline. And so from the midline to the top of my graph, or the midline to the bottom of my graph. So there's the top of my graph, and then here is the bottom of my graph, right? So this is what we call the amplitude of the graph. And so notice that for the regular or the basic sine graph, so this is just the graph of sine x. I'll just write this here so we can just be clear. Sine x, this is just a basic sine x graph. And so a standard sine x graph, the amplitude is going to be 1. If you saw there, the top of the graph is 1 and the bottom is 1. And so the amplitude is going to be 1. Okay. Now we can also calculate the amplitude. There are times that you're going to need to be able to calculate the amplitude of your graph. And so you can use this formula where you do maximum minus your minimum. So the maximum point of your graph minus your minimum point of your graph. Okay, and divide by 2. So you're finding the average between your maximum and minimum point. That will give you your amplitude as well. All right, so now let's look at our phase shift. When we talk about the phase shift, I like to say it's the starting point of your graph. Where did your graph start? Okay, so here is my graph. My regular sine graph usually starts at 0. Okay, phase shift is talking about the x coordinate point for where your graph starts. And so here, if you notice, the phase shift is 0. But just want us to note, these are just for your standard graphs. But if you have a graph in the form y equals a times sine of x, sine of bx minus c plus d, there are quite a few things that we can use these letters a, b, c, and d to represent. So, for instance, the period is going to be, in terms of d, the period is going to be 2 pi over the absolute value of b. And I'm going to look at an example for us so that we can see where these come into play. Your amplitude is going to be the absolute value of a. So that's if we're looking at this type of graph, right? And then your phase shift, right? Your phase shift or your starting point can be calculated by doing c divided by b. Now your midline, is going to be the point, or it's going to be a line, of course, y equals d. And in this instance, if you are familiar with shifting graphs, right? So if you were to shift your graph up or down right now for the basic y equals sine x graph, your midline is at 0. Because if you think about this, right? If we look at the other type of graph that we just looked at, y equals a sine of bx minus c, right? And then plus d. For the basic sine graph, d is 0, okay? A is 1, our amplitude, right? Because it's 1, like we said. Okay, and B is also 1, and C is 0. And so when you put all of this together, if you do 1 times sine of 1x minus 0 plus 0, you will come back to your sine of x. Just wanted to show